Hello, everybody. Welcome to the last lesson of our Module 19, Lesson 5. P187 and 188 is where we are today. So let's take a look at what's happening and see what we know. We are identifying and graphing relationships and patterns. So, Deanna makes lemonade for her friends. The recipe is to add 3 cups of water for every 1 cup of lemonade mix. So our rule is going to be add 3 and 1. So if we have 1 lemonade mix, we have 3 cups of water. If we have 2 cups of lemonade mix, we have 6 cups of water. If we have 3 cups of lemonade mix, we have 9 cups of water. So now we're going to graph. If we make these ordered pairs, we would have 1, 3, 2, 6, and 3, 9. So we graph those. 1, 3, 2, 6, 3, 9. That's what it would look like. We need to label. So 1, 2, and 3, those are the X coordinates that we have in our pair. Our X-axis is going to be lemonade mix. I'm just going to put lemonade, and it's in cups. Our 3, 6, and 9, those are our Y coordinates. That's going to be water, and again, in cups. So now we have everything labeled. Mine's a little sloppy. I tried to write sideways, sorry. How many cups of water does Deanna need to add if she uses 8 cups of lemonade mix? So if we were to continue here, and we want to get all the way to 8, look at the relationship. For every cup of lemonade mix, we have 3 cups of water. So we have 3 times as much water as lemonade mix. So if we get to 8 cups of lemonade mix, we need 3 times as much water. So that would give us 24 cups of water. All right. Elsa says that George's chili is hotter than Lou's chili because the graph shows that the amount of hot sauce in George's chili is 3 times as much the amount of hot sauce in Lou's chili. Does Elsa's claim make sense? All right. So let's compare. Let's start with George's chili. This is a bowl of chili. For every 1 bowl of chili, there are 3 teaspoons of hot sauce. So 1, 3. We have 2, 6. And we have 3, 9. And we have 4, 12. So that's George's. I'm going to put a G. George's chili. Lou's chili, on the other hand, for every 2 bowls of hot sauce, I'm sorry, 2 bowls of chili, he has 2 teaspoons of hot sauce. So 2, 2, 4, 4. We have what? 6, 6. And we have 8, 8. So again, she says George's chili is hotter because the amount of hot sauce is always 3 times as much. What would be the comparison for Lou's chili? It's just 1 time, right? It is the same, the bowl to the hot sauce. So does her claim make sense? I think it does because of the fact that Lou's hot sauce, it's the same, the bowl of chili and the hot sauce. There's 3 times as much in one. If we went with 1 bowl for Lou, it would be 1 to 1 for the hot sauce. 2 bowls, 2 to 2. 3 bowls would be 3 to 3. 4 bowls would be 4 to 4. So I do believe she is correct. All right, good job, Elsa. For our test prep, the table shows the number of muffins made using different amounts of flour. how many muffins can be made using 5 cups of flour? Let's look at this relationship. 1 cup of flour is 12 muffins. So the number of muffins is 12 times the amount of flour. So if we were extending this table out and we want to get to 5, and the number of muffins is 12 times the amount of flour, what would 12 times 5 give us? That would give us 60, letter C for our answer. Xavier follows the rule, add 2 to the side length of a square, and learns this results in the rule, add 8 to the square's perimeter. Write 4 ordered pairs relating to the side length and the corresponding perimeter. If you want to start at the origin 0, 0, we're not going to count that as one of our pairs. We have 2 to 8 for our rules. So for each one, we're going to add 2, we're going to add 8. We're going to add 2, we're going to add 8. One more, add 2, add 8. So that would be our ordered pairs. The table shows the relationship between the number of hours Jamie works and the amount of money he earns. Select all the amounts that Jamie could earn working different whole numbers of hours. So if we look, he earns 7 times as much as he works. So for each hour, he gets $7. So if we continued on, 2 would be 14. 3 would be 3 times 7, 21. 3 times 4 is 28. I guess we could look for multiples of 7, right? Should be 42 and 63. Those would be all the amounts he could earn working whole numbers of hours. We've not gotten to multiplying decimals. We are going to work on that a bit. So here's a little sneak peek instead of a spiral review. I want you to think of this just as 63 times 13, just a regular multiplication. You're going to do the work the regular way, 0 placeholder, 3, 6. We're going to add 9, 11, 8. Once we have an answer, we're going to look back. And I see 2 decimal places in my original problem. So I'm going to start where my invisible decimal would be at the end of the whole number. And I'm going to move to the left 2 places. So our answer would be 8 and 1900ths. So that's what we're going to be doing coming up. So there's a little sneak peek. We know how to divide 728 divided by 19. So how about we try, what do you think? 19 goes into 72 how many times? Maybe 3 times? I think I'm going to try 3. 9 times 3 is 27. 3 times 1 plus 2 is 57. I think I might be able to go with 4. Maybe? Maybe not. Let's see when I subtract. Oh, maybe not. I subtracted. I got 15. That's less than 19. I'll bring down my 8. And this time I think 19 goes into 158. How about, 6. What's 9 times 6? Let's try 6. If I double, because I did 3, 6 would be 114. I don't know if that's going to be enough. Let me try guess and check with a 7. 7 times 9 is 63. 7 times 1 plus 6 is that 13? Oh, I'm still off. I got to go with an 8. Guess and check. Guess and check. Go with that 8. Let's see what we get this time when we subtract. Good thing I'm using my erasable pens, huh? 8 times 9 is 72. 8 times 1 plus 7 is 15. So then we would end with a 6. So you could say 38, remainder 6, 38 and 6/19. It doesn't really tell us which way to write it. 38, remainder 6 would also be acceptable. And I think that's it. That is the end of our lesson and test prep. We will continue tomorrow with our review and have our little quick quiz and project that I'll talk about in class next time. I will see you then. Bye.